Alright, it's time to give our CNC some brains. CNC electronics is a big topic to go over, so today we're just going to hit the basics. We need some way for our CNC software, in our case Mach 4, to talk to a bunch of motors, switches, and valves. The hard part is that it needs to do this in real time, which actually gets pretty tricky in a Windows-based PC, but that's a whole nother bag of worms that we might go into in a later video. Back in the day, you'd need to use a parallel port and some special drivers for this, but these days, there's a much better solution. Enter Smooth Stepper. These boards translate either a network or USB signal into an old-school parallel port. It also has some clever buffering to keep the ADD nature of Windows on track. From there, you need a breakout board, or Bob, to split these signals into a more electronics-friendly interface. We're going to use this one because it mostly covers all the stuff we want to plug into it. Speaking of things we want to plug in, there's a whole list of stuff that I will link to in the upside down, but here's an overview. We've got motors, a spindle with a variable frequency drive, home switches, valves for a pneumatic tool change and mist cooler, and a bunch of power supplies to power everything. That's the basics. Let's build it. Man, oh man. It's nothing like seeing 3 or 4 months worth of research and work go by in like a 6.5-minute video. You know, I think one of the things that people really underestimate in a project like this is just the sheer amount of decisions that have to be made. I mean, there's a dozen components in here that they all have to work together. You have to do the research. You have to have the right power supplies. And you don't always make the right decisions at the time either. We've made a few mistakes along the way. I think the way these black bars came out are all wrong. We're gonna do something to make that look prettier. The other thing is you might be wondering why we have such a large box in here. You could probably get away with something a little smaller, but honestly, this is the third box that we have bought for this project, and they have gotten just progressively bigger. I think this was the second one, and even this wasn't quite big enough to fit everything in, so that's part of it. One piece of advice I might give you if you're doing an electrical box like this, get one with a back plane on it like we have that can be removable. That was a huge, huge help, so definitely do that. But I think that's going to do it. Next time you see this machine, I think it's going to move. All right, see you guys.
I was hoping maybe we could have a little dialogue about that.
All right, Sharoth says, everything is good and fine, but that beep sound with the color bars is too much irritating.
Oh, let's try this one instead. Nathan says, what was the material you used for the new probe arbor? It didn't look too hard when you turned it to size, which to me misses the benefit of grinding. I don't think grinding a soft material on the lathe is going to benefit you for accuracy or concentricity.
Yeah, you are right. That was not hardened steel. I think we were using mild steel. We'll probably regrind that out of hardened steel at some point for that reason. However, we do get some accuracy out of the grinder as opposed to just cutting it on the lathe, partially because this lathe is, it needs some work.
Yep.
All right, homemadetools.net says, good job. Feel free to embed your homemade tool vids on our forum. You're one of us.
One of us!
I just checked it out. It looks like you have some really cool stuff over there. We should probably do that. Link in the diddly.
All right, Joel asks, was that silver anodizing for just surface protection?
Yes, it was. Plus, we couldn't agree on a color because Mike hates all the good colors, and he's stupid. Trucking Gator.
Speaking of one of us.
Yeah. Says, you should use the tool post grinder to grind the latheways.
Oh. I like that. I'm not sure how that would work, though. All right, Tommy Gun Machining asks, did you consider mounting the tool post and completing the final boring operation with the boring head on the lathe?
Yes, we did, and you could do that boring head in either the lathe or the mini mill, or you could do it with a line boring operation like Kieth Fenner does. We'll leave a link in the thing to a video of him using that. But mostly, we just wanted to use some cool 3D adaptive tool paths in the Tormach, so.
Heck yeah.
That guy says...
That's a great name. How do you get that name on YouTube?
One of a kind. How would you adjust the height of your new tool grinder attachment?
Okay, so the tool grinder attachment technically doesn't need a height adjustment. We got it real close to center just in case we're boring something that is just a little bit bigger than the grinding wheel itself. But it turns out it doesn't really matter so much on a grinding head. Kind of weird that way.
Yep.
Ideas asked, also a great name, says, nice work, but that 3/4 inch post for the probe you made, should you not have dialed that in with the 4-jaw chuck before grinding it?
Yeah, we had a couple of questions along this line, and the long story short is that the probe is adjustable. It probably wasn't concentric when they put it together, so no worries there. Leah asks, why do you need a tool post grinder? What does that do that the lathe doesn't normally?
Yeah, that's a great question, and one we probably should have covered in the last video. To me, there are 2 advantages to having a tool post grinder on a lathe. One is you can cut hardened materials, although Stefan actually just had a video where he cut carbide using regular lathe tools, which was pretty incredible. Yeah. But the other advantage is it has really low tool pressure. It doesn't fight the tool very much, which means if you've got a clapped out 50-year-old lathe refurbished by amateurs, you can still get pretty accurate parts.
Veteran Bicycle asks, those socket head cap screws should only be connected to one of the 2 faces.
That generally is a good rule of thumb, but there are a few ways around it if you want or need to do it in a design. What he's talking about is the tendency for a part that's spanning a joint to pull the joint apart or mash it together. If, for example, you use countersunk holes, your tolerances would have to be impossibly good for it not to be putting some force on the part one way or the other. Over-constrained is the working term.
But socket head cap screws can float in the clearance hole a little bit. You could even make the hole oversized or slotted if you wanted a lot of wiggle room. Our tolerances were pretty good since it was all drilled half on the CNC and half on the mini mill using the DRO, so we knew there'd be plenty of clearance and even help to keep the center bolts from acting like a fulcrum. I think you guys kind of came to the same conclusion in the discussion, but we wanted to mention it, since we kind of glossed over it during the video, and it's definitely something to look out for.
Yep. Oh man, can we get more of that crazy rainbow unicorn thing?